We're going to be talking about how we can measure the inside of a shape. We just talked a lot about shapes in our geometry unit. We see shapes every day. This classroom is a shape. Your desk is a shape. Your car is a shape. It just might not be a shape like a trapezoid or a rectangle. It's more of a irregular shape. Shelby? So we've got quite a few shapes in our world. How do you think we could measure inside of a shape? How do we do that? Give me ideas of how you might measure inside a shape. Victor, what do you think you could do?
Maybe if you feed a square and like you write this or that.
Can you explain that a little bit more? Just don't put your arm on it because it thinks that you're writing with your arm. We've got a shape. What shape did you make?
A square.
Okay.
I mean, no.
A rectangle. And how are we going to measure inside that shape? Okay, so why did we put more shapes on the inside?
Because that's how we make a shape in here.
Okay, so maybe we can add things inside and use that to count.
Okay. Maybe we could, like,
Can I help you with some words?
like that too.
Okay. So I think what you're trying to say is you can fill, I'm writing, that means you're writing, a shape with things. Could be squares like you did in this one. Fill a shape with things and then count those things. Is that what you're trying to say?
Mm-hmm.
Awesome. All right, go back to your seat so we can write this down. So Victor had the idea that maybe we could fill it with something and then count those somethings. Will, what do you think?
Well, I think, well, maybe you should make it like three-dimensional, like. Well, I can't really draw it, but like fill it with unit cubes.
Okay, so similar to what Victor was saying, but what if I want to measure a not three-dimensional shape? That would totally work. Will's talking about if I had, like, let's say a box, and then filled that box and counted those unit cubes or unifix cubes or whatever you've used. But let's say I want to measure, like, the top of my desk. I'm not talking about filling my desk. I just want to know about the top of it. Gwen, what do you think I could do?
If you want to measure like the top of your desk, you could measure like what is like inches or centimeters or like forms.
All right, so we're gonna use things like inches. We might use things like centimeters. So we're talking about those measurement words you've seen before: inches, centimeters. Shelby?
If you have like a rectangle,
Uh-huh.
then you have like a ruler the size of like a foot,
Uh-huh.
and your desk is as long as a foot. You want to know how much feet it goes down? You can like stack up the ruler on the desk.
Okay, so similar to what Victor mentioned, if I have my desk, I could fill it with rulers, kind of like this. Is this what you're talking about? And then count my rulers across, could be. Lincoln, what are your thoughts?
So you have to make sure you're using the right measurement.
Uh-huh.
It doesn't make sense to measure a water bottle with meters.
Love that. So Lincoln is talking about we need to make sure we're using the right tool. Inches and centimeters are really small, so they make sense to measure things more carefully, like a water bottle or even your desk. But we have really big units of measure. We have things like miles. Would it make sense to measure a water bottle using miles?
No.
No, it doesn't make sense. That is way too large, and it's not going to give us an exact answer that we're looking for. Michael, what are your thoughts? How could I measure inside of a shape?
Like if you use the array, like if you drew like a rectangle and like or no like a square, and since the sides are even, you would have to make it like say like 5 dots on each line,
Oh, okay.
and then fill in the dots in the middle of it, and then like draw a little square in the middle.
So what Michael is remembering is he said, oh, an array kind of fills up a space. I can maybe use what I know about an array, similar, filling up things with other things and then counting those things. When we measure, I need you to write this down because it is important. All of it? All of it. When you measure the inside of a shape, you have to measure 2 things at once, which is kind of crazy to think about. You have to measure something called length and something called width. Raise your hand if you've ever heard of length or width before. Yeah, we might have heard those words before. So Jacob, we're writing this whole sentence down, okay? I like to remember length because to me length almost looks like long. Do you see where it almost looks like long?
Yeah.
It is how long a shape is. To make that easy, let's think of like a square or a rectangle. X, for example. And then I'm just going to draw a rectangle. So I'm going to have 2 lengths. One is right here, length. Oops. This is a length, and then this is a length.
Why is there a G in the word like?
Because English is weird.
That's not French or something.
No, well, we borrow a lot. English borrows a lot of words from other languages, so it's probably a different language that we borrowed that word from. So we've got how long a shape is. When we're measuring how long a shape is, this is where we're going to use those measurement words that Gwen and Lincoln were talking about. We're going to be using words like meters or yards or inches or feet or miles, whatever unit makes sense for what we're measuring.
It can also be like, if you're like measuring space or whatever, you can use AUs.
AUs, astronomical units. Yep. Whoops.
Wide.
Not wide. I meant to put width. But width is
Wrote
very
wide again.
similar to how wide. Wide. We see wide almost looks like width. A shape is. On this shape, I have 2 widths. In this case, it's going to be right here. Oh, why did that not turn? There it goes. So here's my width. And then here's my width. Now I will let you on a little secret. Length and width, they don't have a specific spot. Lots of people make the length the longest one But if I wanted to call this width and then this length, I could. It doesn't really matter.
So they can go in
I know. And I don't want you to get confused on where they go. Just make one side length and one side width. It doesn't really matter. Most people use length as the longest side because long length. But in the math world, it really doesn't matter. Yes.
You measure things in years.
Can I measure things in years? Sure. I'm just not going to be measuring objects in years. Like you measure your age in years, right? That's not something that I can really measure. But yes, time can be a measurement. It's just not going to be a measurement that we're going to be using a ruler for.
Like a timeline?
Timeline is like the picture version.
I feel like that
Like a
would kind
model.
of be like more in math, because like if there was 20 to 20 like 2 years.
Yes?
It's like kind of like in like the length. It's like kind of like you were saying, like
When we are measuring two sides at once, hang on. When we are measuring two sides at once, we're measuring those lengths and widths. That means we're going to have to use something that has a length and a width. Most people use squares. We are going to use square units. Write this sentence right here. We use square units because we need something that's going to measure those two things at once. Well, you were talking about making it three-dimensional. We're not playing in three-dimensional shapes in 3rd grade. You will do that more in 4th grade. We are only playing with 2D shapes. Does anyone know what that D in 2D stands for? It's the same D as in 3D. Brayden, do you know what it is?
Dimensional.
It is dimensional. Dimensional is a really fancy way of saying how many sides are you measuring. If you are measuring in 2D, how many sides are you measuring? 2. Length, width. If I measure something in 3D, how many sides am I measuring? 3. Length, width, height.
Oh yeah.
We're not messing with 3D this year.
Oh,
You will do 3D in 4th grade. This year we're only focusing on 2D. We're only taking 2 measurements, length and width. Sean?
Don't scientists believe that there's some kind of fourth dimension?
Yes, they have thought about 4th dimensions before. It kind of goes diagonal. It's a very complicated thing. I'm not an expert at it. But yes, so we have 2D, length, width, 2 measurements. Yes.
it also that like 3D is kind of like it's like kind of like when we made like kind of like a 2 like D.
We're going to use these square units to help us find this area. Come on now.
Do we draw a square?
Let me see if I can get my picture to show up, because I should have a picture here. So let's look at this shape. I've got a rectangle. Go ahead and draw a rectangle in your notebook. I've got my rectangle. And I've used those square units, and I filled the shape with square units. Do you see that? I don't have any extra spaces. The whole thing is filled up.
Square unit.
So now I'm going to count how many square units I used. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the area of this shape, I would write area equals 10 square units. Yes.
So the area is like this
space inside of it?
It is exactly like that, the space inside. I love that definition, Lincoln. We are measuring the space inside. We use squares to fill up the space inside and then count it. If this square was, let's say, 1 inch by 1 inch, then instead of 10 square units, I would say 10 square inches. Because that's how big my squares are. If I had a really big square and it was 1 square foot by 1 square foot, I might say that it is 10 square feet. Victor?
You have to draw the like square.
So next thing we're going to do is we're going to be working with some square tiles to create some different shapes that have an area of 6 square units.
7.
So, or sorry, 7 square units. Yes, 6. We're going to be working with some tiles. As you make your shape, you're going to trace them in your notebook. So don't put your notebook away, but we're going to be building our shapes in our notebook. All right, I saw a lot of square units, or sorry, shapes that look like this. You just had 7 squares. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. I saw a lot of square units that look like this. You might have put your 6 together and then had one sticking out somewhere. You might have had a different configuration. As long as you have 7 square units, you made a shape with an area of 7. If you have not traced it in your notebook, trace it in your notebook now.
Do we write the 7 squares?
Next to it, you need to write area equals 7. And because we're measuring 2 sides, we have to put square units, because that's a little bit different. I like to shorthand square to SQ, and then units. That way mathematicians know, okay, you were measuring 2 sides at once, a length and a width. That's what that square unit means. All right, let's try a new shape. Using your square tiles, make a shape with an area of 12. All right, I saw some really cool shapes. I saw shapes that looked like this. We had 2 rows in our shape. I saw shapes that had 3 rows. Yep. What is our area of this shape?
12.
12 what?
Square units.
Square units, that's important. We need to talk about how we were measuring 2 sides, so we need square units.
Is there something as triangle units?
Yes. So, Gwen, another way of writing 12 square units is I can write 12 units squared. Have you ever seen that before?
Yeah. No. Yeah.
So, Gwen, when you're measuring a 3D shape, right, you're going to have 3 dimensions that you're measuring. You with me?
Yeah.
I might write 12 units. Guess what I'm going to write?
Square.
Nope.
Triangle.
It's called cubed.
Oh.
But I only write that if I'm measuring 3 sides. Am I measuring 3 dimensions?
Oh, because it's cubes. There's 3.
Because there's 3D. You got it. Alright, next shape. Using square tiles, create a shape that has an area of 8 square units. 8 square units. Go ahead, Will. Saw a shape that looks like this. Does that have an area of 8?
Yeah.
Count it. 1, 2, 3, 4, 5, 6, 7, 8. It does. I saw a lot of shapes that kind of look like that array that Micah was talking about. Like that. Love that. Love that.
Can you say mine? I would like to. Can you say mine?
don't know if I can draw that one, Gwen. That one's pretty cool.
It's a staircase.
So Gwen did 2 shapes, and then 2 shapes, and then 2 shapes, and then 2 shapes. 1, 2, 3, 4, 5, 6, 7, 8. Does have an area of 8.
If you take away all these,
Don't forget, when you draw it in your notebook, area is, what's the area of this one?
8 square units.
8 puppies.
8 square units.
8 square units, or you could write it mathematically, which looks like this. 8 units
square.
squared.
You're right, 8 square units.
That's totally fine. Both of those are correct. This is just the math language version. If you would rather write the English version, square units, that's fine too. Both of them mean the same thing. Yes. Yes. Next one. Create a shape that has an area of 4 square units. 4 square units. Don't forget to trace it in your notebook. All right, I think a lot of us thought of this shape at least first. You might have made something more creative with your 4 square shapes. 4 square unit shapes. What's the area?
4 square units.
4 units squared.
You could say 4 square units. You could write it. You could write it in English. That would look like this: square units. You could write it in math language: 4 units squared. Both of those are acceptable. Yes. Not right now because we've got one more to do. Quickly. All right. I think this is the last one. Yes, you're gonna have to pull your pieces together. You're not going to be able to do it separate if you don't have enough pieces between the 2 of you or 3 of you. Put all of your pieces together. This time you need a shape that has an area of 24. Alright, next to your shape, you need to write the area. What is the area of the shapes that you created? What is the area of the shape that you created, Devin? 24 units or square units. That'll struggling to write. 24 square units.
Yes.
You could also write 24. 24 what?
3 units.
Units.
It's 3 on each one.
What is it? Square. Units squared. That'll work.